Hi guys, today we're going to be looking at a fairly simple experiment to do with light, colour and the absorption of light and how different colours can affect the perceived heat of an object. Now to do this, all you'll need is a couple of different colours of card. Especially important are white and black card. I think this one's actually a sort of really dark blue, but we'll say it's black. You need a sunny day, which I haven't got today, and so this experiment isn't actually going to work, but I can teach you the principles of it. And you'll also need an infrared thermometer, which if your school doesn't have one, they're really, really cheap to pick up. So with those three things, let's get started. Now, the background behind this, and this is kind of just the knowledge that you'll need to impart to your class in some way before, is that when we see something as white, it's actually because it's reflecting all the light that's hitting it. So white light is produced by a mixture of all the colours of the rainbow at the same time. When we see something as black, it's because it's not reflecting any light, it's absorbing all the colours of the rainbow. Now, this is just kind of an assertion that we often just give to our kids. You know, it's our typical teachery thing of, right, here's some facts that we need to give you, and trust me, they're true. As a scientist, or as scientific thinkers, we should be trying to think, well, okay, these are assertions, let's test them and see whether they actually hold up. So we know that there's a relationship between light and heat as well. Okay, so infrared is what produces heat, and that's a type of light. Light and heat are basically the same thing. So that's why we have our infrared thermometer. So in principle, if something is white, it's reflecting all colors of light, including infrared light, and therefore it should stay cooler. It shouldn't absorb as much light or as much heat, and so it should stay cooler. Whereas something black should absorb more infrared light, as well as all the other colors of light, and so it should get hotter. So what we do is we leave these out on the windowsill on a bright sunny day for maybe half an hour to an hour, and just let them do their thing. Let them absorb or reflect the light as they'll do naturally. Then, after that amount of time, take your infrared thermometer and just sample each one of them. And you can get your kids to come up with their hypothesis and say why they think that. You could write it up using experimental methodology, and have your aim, hypothesis, materials, method, results and conclusion. But when you actually take the infrared reading, and I'm not going to get a decent reading today because they've not been left in sunlight, you should notice really quite a marked difference between the white one and the black one. What can be more interesting though is to get different colours as well, and this is where I may be doing this variant with P7 classes or even much older, maybe up to high school. Take different colours of paper and see how the heat from each of them varies, and try to figure out why. So is red hot? Does red become hotter than blue? Why or why not? And you can actually look at the colour spectrum produced by our sun and draw some conclusions based on that, based on the colours of light that are more likely to be reflected or absorbed. So that's a way of sort of pushing it that little bit further if your class are up to it. But at the simplest level, just look at the difference between white and black, and the heat difference there is quite simple. And it's a very good way of proving that white reflects, whereas black absorbs. Cheers.